Hello, just wanted to jump in and talk about a few things this week. And the first thing we're going to talk about is trying to remember where we're going with this. We're going to talk about pointers and parameter passing in C++. So I mentioned last week a little bit about pointers and pass by reference and pass by value, and I want to show what they mean. So what does it mean to pass by value? What does it mean to pass by reference? And how pointers work and why they're important. I have a code space set up here. I'm just going to go ahead and create a file called parameter passing. If I can spell it correctly, we'll call it parameter passing.cpp. Okay. And of course, we're going to always start as usual with our program, which is going to include IO stream, and we are going to use namespace std, and then we are going to create a main file, a main function, and inside that function we are going to return the int. Okay. So it's about passing by value. Above this function here, this time I'm just going to go ahead and write this function up here. I'm just going to say we have a function that is pass by value, and we are going to have a parameter of x into this function, and we are going to say x plus equals 5, so that we'll add 5 to x and reassign it. And I'm going to output this as inside pass by value. X equals, and we will say, there it goes, x, and then we will end that line like that. Okay, perfect. Okay, so what will happen is, and I'm going to go and call this function from main, and to call this function from main, I'm going to just create a number like 10, and we are going to pass by value that number. Let's make that a proper parameter, and then we're going to say, I'm just going to do this here after pass by value, and you can see what this looks like after pass by value. So pass by value starts at 10, and it goes to the pass by value method. X is done, so 5 is added back to 10, which gives us 15, and this should give us 15. And what's interesting is when I pass by value, a copy is made of that integer inside this function, so when we leave the function again, it's going to output 10, right? Well, let's say num. Let's make sure this, I just copied that down, so we're going to make this both num. So num is 10, we pass num in as x, x becomes 5. We can actually make this x if you wanted to. Let's just make that x to make it a little more confusing for everybody. Let's make this x so that you see that there are 2 x's in this program. Alright, I'm going to go ahead and save this parameter passing. Alright, I'm going to compile this code. So g++ parameter passing dot cpp dash o, we'll call it param pass. Alright, here we go. Num was not declared in the scope. We're making this x instead. Alright. Let's run it again. And I'm going to run that code, and now you can see what happened here. That copy was made. The 10, a copy was made inside pass by value, a change was made. You can see the 15 was output, but when we leave that method, it's still 10. nothing really changed. So pass by value makes a copy when we do a method or a function call. So what if we wanted to make a change and keep that change steady? Like what if we wanted it to work? Like I wanted to make a modification inside a parameter and I wanted it to modify the original value. Well, to do that, we would do something called pass by reference. Let me create a function called pass by reference with int x, but since we're passing by reference, I need to go ahead and put that ampersand in there. That's going to pass a reference to the value. What happens now is a copy is not made. What is passed to the function is the reference to the memory address that's being used. And so when this is modified, it modifies the actual value. So we're going to do the same thing. We're going to copy this in and we're just going to say inside pass by reference. And we're going to, at the bottom, we're going to say pass by, instead of pass by value, we're going to say pass by reference. And we are going to copy this down and we are just going to say after pass by reference, and you can see what this will look like. Alright, and let me run this code real quick. Now you can see now that we passed by reference, it referenced that memory location, it made the modification, the value was indeed changed. And so we have a proper thing here. And that's kind of what pass by value and pass by reference does, right? So, let's talk about pointers, right? A pointer stores the address of another variable, and we can use it to modify things. So I'm going to go ahead and create a pointer. Testing. Okay, cool. I'm going to, real quick, got an audio problem. Let me check this real quick. Okay, I got everything fixed. Okay, so we're going to use this pointer, and when we use a pointer, to reference that pointer, I'm going to use an an asterisk. So it's going to look like this. It's going to look like int star and x. Right? So now, instead of passing a reference, we are going to pass the pointer. And I'm going to go ahead and say, we'll copy this down real quick as well. Okay, so we're going to do the same thing below. I'm going to create using pointer, and you will see what happens. And oh, sorry, I need to create a pointer to x here using that asterisk. Sorry, I don't know what I'm doing here. I need to do the ampersand to create the pointer. It's going to look like this. Alright, everything looks good now. So we have created the pointer, and the pointer is being passed in as a pointer. And what you will find is that that pointer functions a lot like the reference. Okay, so when we printed out x, let us print out star of the asterisk x instead, so this makes more sense. Alright, there it makes sense. Okay, so inside using pointers 20 and after using pointer 20, what this was here is the actual memory address, because what the pointer does is it actually acts as that memory address, and what you're seeing is a point to the memory address. So when I printed it, it printed that out. When I put the asterisk in front of the x, it's going to return the value that's held in that memory address, and this presents as kind of like a hexadecimal presentation. Notice how we pass the ampersand x. That's the address of num. The function uses value or asterisk at x to change the value at that address. Inside the function, asterisk x is 20. After the call, num is also 20. So let's just slow down and look how pointers store memory addresses, right? So I'm going to go ahead and temporarily add a set of code to main. So we're just going to put this in and go from there. Okay. And I'm going to go ahead and comment out what's below here so that this code isn't going to run. Okay. For right now. Okay. So we're going to run this code and we'll talk about it. Let's clear the terminal again. Let's run this code again. Alright, and what you'll see is the value is 42. The address of that value is that memory location. So the pointer, when we instantiate a pointer, it's going to point to that particular address. Right? And the dereference pointer, so when we dereference it, we're pulling the value out, and that is exactly 42. Alright, so let's talk about what we've learned. If you pass by value, you're going to copy the variable into the method. If you pass by reference, you're going to send the actual variable directly. So it doesn't create a copy, you send the reference to that address. If you use a pointer, you're sending the actual memory address, and you use the asterisk to dereference it and access the value. Understanding these topics, understanding these concepts, will give you precise control over how data flows in your programs. Next time we're going to use these ideas inside of a class. Alright, and we'll stop for now.